Hey everybody, welcome to lesson 4 of unit 4, trig functions of any angle. This is a graphic organizer that you need to print out before you go any further. It's underneath documents, under unit 4, lesson 4, it says graphic organizer. So go and print that out now. Okay, next step. You need to fill in this information. If you want to know where this information came from, well, what can I say? You should have been in class. But fill this stuff in. Pause the video. Make sure you get all this stuff. Okay. Now that you have that top filled in, here's the bottom information. There's a good amount down here that you need to make sure that you mark as well. The formulas and this handy little graph on the side. So pause the video. Copy that now. Okay. So we're going to be referring to that graphic organizer for the rest of this lesson, which starts right now. So, trig functions of any angle. First of all, let's look at what we're working with. We're no longer working directly on a unit circle for some of these problems, right? Sometimes we can have a coordinate xy, and we're going to assume that our vertex is at the origin. Here's our initial side and our terminal side, okay? That means that we have a height of y and a length of x, which will allow us to use Pythagorean theorem to figure out what the length of r is. So instead of r being 1, which has been the radius with the unit circle, now we can work with any size circle and figure out what our radius is just by using this formula. So we're going to need this formula. And because sine is no longer y over 1, our radius has changed, now we have these new trig functions. So you need this formula to find the value of r, or possibly maybe an x or y, depending on what you're given. And we're going to need these formulas. So quickly jot those down. Alright, so here's how our problems are going to work. I'm going to leave this information up so we can still see it. Okay, we want to let 3, -4 be a point on the terminal side of theta. So it's going to be a point somewhere up here, right? And we want to find the values of sine, cosine, and tangent. So we know our x and our y coordinates, but we need to find r. So we use our r finding formula, right? We have square root of 3 squared plus -4 squared, all under the radical. We're going to quickly solve for r, and we find r to be 5. Now we're going to work with only positive because, remember, r is a distance, it's a radius, so it should be positive. So now we have our x, our y, and our r. And we know what each of those are supposed to be in terms of r, y, and x, right? Sine of theta, that's going to be -4 over 5. Cosine of theta, it's going to be x, which is 3 over r, which is 5. And tangent is going to be y over x. Okay? So here's an example for you to try. Make sure you have those reference angles handy, formulas. Okay, pause the video and try this one out. Resume when you're ready to check your answer. Alright, so what did we do last time, right? We read the problem. We have -1 and -6 as a point on the terminal side of theta. We want to find sine, cosine, and tangent. So we already know our x and y, so we need r. Using our r finding formula, right? R is the square root of -1 squared, which is 1, plus -6 squared, which is 36. We get the square root the square root of 37. Now, that's the square root. It's not a perfect square. We're going to leave it as square root of 37 because if you know anything about me, you know I hate decimals. This is a really nice number to work with, but we're going to have to rationalize because as you can see, r is going to be on the bottom for sine and cosine. Right? We know sine is going to be negative 6 over r, which is radical 37. We don't want that down here though, so we have to rationalize. Our fancy 1 is root 37 over root 37. That gives us root 37 squared. Those cancel out, right? And we're left with negative 6 times the square root of 37 over 37. If those simplified, we would, but they don't. So this is good enough for sine theta. Cosine, going to be very similar. We're going to have negative 1 over root 37. We rationalize. And we get negative 1 times root 37 is negative root 37. That squared, those radical and square eliminate. So we get negative root 37 over 37 for cosine. And last we have tangent, way easier than the other two because it's just going to be y, which is negative 6 over x, which is negative 1. Those negatives cancel and we get tan as just plain old 6. I hope you got those ones. They weren't too bad, right? Just working with that R formula and these sine trig equivalency. Anyways, alright, so we've got a couple more problems that we're going to work with. They look a little bit different this time. So we're going to need our reference sheets, I think, a little bit for these ones. Okay? We are given sine of theta as negative 2 over 5, and tangent is going to be a value greater than 0. And we want to find the value of cosine. So, we do need that reference sheet, and here's why. We only know a little bit so far, right? We know sine is going to be negative, and we know that sine is y over r, and that negative is assigned to y because r is a distance, it's always positive. We also know that tangent is positive, and we're looking for cosine, which is x over r. So we have a y, we have an r, we need an x, and we know sine is negative and tangent is positive. So that's when we look to our reference sheet. Okay, we want to look for where sine is negative. So let's see, sine is negative down here, but we want tangent to be positive. So tangent's positive, sine's negative in quadrant 3. This information is something that we really need here, right? Because we need to know x, and it's telling us that x is going to be negative. So we're going to keep that in mind. Okay? So we still need to figure out what x is. We're going to use our r finding formula. And we're just going to start plugging in, right? 5, I'm looking for x. We got negative 2 for y. Okay, I'm going to square both sides to get rid of the radical. So we got 25. And let's see, plus 4. Subtract 4 from both sides. 21 equals x squared. And take the root of both sides, get rid of that square. And we got x equals 21. But we already said, after looking at our graphic organizer, that we need a negative x value. So here's what we've got. We got an x equals negative square root of 21, which is what we need. And we have r as 5. So when we do cosine, which is what we're looking for, we want negative square root of 21 over 5. And there you have it. That's the value of cosine. Alright, so maybe that went by kind of fast, and that was only one example. Let's take a look at a different function, different value. Right? We have cosine of theta as 2 over 3. That's positive. And we're looking at tan that's less than 0. That's negative. And we want to find sine. Okay, so we've got a positive cosine, a negative tangent. Cosine we know is x over r. And we want sine, which is y over r. So we need the y, right? Well, cosine is positive, tangent is negative. So I want to look for where tan is negative. Tan's negative in these quadrants. But I want cosine to be positive. And here is where that happens, quadrant 4. Cosine's positive, tan's negative. What I know is that x is positive and y is negative. I need to keep that in mind. Okay, I have a negative y value. So let's find what y is equal to. Our r finding formula, we just start substituting in, right? 3 equals x they give us as 2. Let's square both sides. So we got 9 equals 4 plus y squared. We'll subtract 4. So 5 equals y squared. And we take the root. Y equals the square root of 5. But we said a second ago that y was going to be negative. So here we have y equaling the negative square root of 5. And r is equal to 3. That's what we needed for sine. So our final answer, negative square root of 5 over 3. Oops, I kind of wrote a little bit through our answer there. So you have 2 examples that you can look at. And an example for you to try on your own. Sorry about that. Something popped up on my computer. Anyways, try this example, pause the video, and check when you're ready. Okay, so let's walk through it step by step. Right, given cosine of theta is negative 3 over 7, tangent is greater than 0, and we want to find the value of tangent. Well, we have a negative cosine, which is x over r. That negative is assigned to x. We have tangent greater than 0, so tangent's positive. And we know tangent is y over x. So we have x and r, we need y. And we need to figure something out about the signs, right? We know x is negative and tan's positive. So we look for where that's true on our reference sheet. We want tan negative. I'm sorry, cosine rather negative. Cosine is negative in these 2 quadrants, but we want tan to be positive. So this, quadrant 3, is where that happens. Negative cosine, positive tangent. It tells us that both x and y are negative in quadrant 3. So we want to keep that in mind. Our finding formula, we have 7 equals, that's negative 3 squared plus y squared. Square both sides, get rid of the radical. And subtract 9 to get y by itself, and take the root to get rid of that square. So we get square root of 40. But as we just saw, y in quadrant 3 is negative. So for tan, which involves x, which is negative 3, and y, which is negative square root of 40, when we plug those into tan, negative 40, the radical, negative 3. Oh, we got some negatives that cancel out. So here's going to be our final answer for this one. It's going to be the square root of 40 over 3. Which makes sense because when we look at that graphic organizer, it told us tan, oops, here it is, tan was going to be positive. Alright, a couple more pages to go. A reference angle. Okay, some new notes now. A reference angle. It's the acute angle formed between the x-axis, and the terminal side of theta. So here's our angle, and here's our terminal side. Now, when we were looking at the unit circle before, we would have noticed a pattern that the values that were up here kind of repeated here and here and here, right? And that's looking at that unit circle. But what we would have noticed, which goes along with this information, is that whatever was listed here, those values matched, but we had a negative x attached to whatever that value was. And in the third quadrant, we had the same values here, except that both x and y were negative. So really, we only had to look at that first quadrant information, right? Which here we see it right now. So we really need this information, because depending on what quadrant we fall in, all we have to do is attach the appropriate sign. Anyways, we're going to get to that a little bit later. What we really need to know about reference angles is that depending on which quadrant you fall, you're going to see that the triangle that we have to make to get these values, the angle that we're interested in, is being made here against the x-axis in your terminal side. So long story short, I want to shorten this video up for us as much as we can. If we notice where our angle falls, the quadrant that it falls in, we can find the terminal angle by using these formulas. Okay, if we're working in radians, we'll use the top version. Degrees will work in the bottom version. And that's going to end up getting us these values, and we're just going to assign negative or positive to it. Now you might notice that quadrant 1 is missing. That's because an angle that lands in this quadrant, we use that actual angle to create that right triangle. These ones, we had to create it somewhere different. Okay, so if we have anything that lands in quadrant 1, we just keep it. But we're jumping ahead a little bit. We need to be able to figure out what the actual reference angle value is. So we're going to be working with these formulas. Okay, so here we go. Here's what we're going to be doing. Find the reference angle of each of these. Okay, we have 252 degrees. We need to first figure out which quadrant it falls in. 252 is past 180, not quite 270. It's somewhere over here. So that's our theta. That means that our angle is falling in quadrant 3. So quadrant 3, and we're working in degrees, it's telling us that we want to use whatever our angle measure is and subtract 180, and that will get us our angle theta. So we want 252. We're going to subtract 180, and we will now get our value, see, of 72 degrees. Here we have 61. Well, here's 90, here's 0, so 61 should be in between. We fall, in quadrant 1. As I mentioned, quadrant 1 is going to be equal to the angle measure, so 61 degrees. Working in radians, not really any different. Okay, 7 pi over 4. Here's pi. So I'm working with 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi is all the way here in quadrant 4. Okay, quadrant 4, we're working in radians, so we want 2 pi minus theta. Alright, 2 pi. I'm going to put it over 1. I'm doing that because I notice I'm working with a fraction. Minus 7 pi over 4. I need to multiply by 4 over 4 to make my denominators match. So let's see. 8 pi over 4 minus 7 pi over 4. 8 minus 7 is pi over 4. That's our reference angle. That's this angle right here. Last one, 2 pi over 3. 2 pi over 3. Let's see, here's pi. That's 1 pi over 3, 2 pi over 3. Quadrant 2. Okay, quadrant 2. That's this one up here, working with radians. We want pi minus theta. So pi, which I'm going to put over 1, minus 2 pi over 3. I need to make my denominators match. We multiply by 3 over 3. So 3 pi over 3 minus 2 pi over 3 is pi over 3. So there you have your reference angle. Okay, we just did 4 examples. If you need to rewind and watch those again, go for it. But I've got 4 for you to try on your own. So pause this and resume when you're ready to check your solutions. Okay. You needed your reference sheet for these, right? We're working with 118 degrees, which is past 90 but less than 180. So we're over here in quadrant 2. We're working in degrees in quadrant 2, which says 180 minus theta. So 180 minus 118, you would have gotten 62. Did you get that? I know you did. I know it. Anyways, problem B, pi over 3. There's pi. So pi over 3 is going to fall right here in quadrant 1. No real work extra here. It's just going to be pi over 3. 339. And let's see, 339 is over here in quadrant 4, right? Past 270, less than 360, quadrant 4. Quadrant 4 says 360 minus theta. So 360 minus 339, you get 21. And our last one, 3 pi over 5. Let's see, 3 pi over 5. 1 pi, 2 pi, 3 pi. We're over here in quadrant 2. So let's see. Quadrant 2 tells us pi minus theta. Pi, I'm going to put it over 1, minus 3 pi over 5. We need those denominators to match. So let's see, 5 pi over 5 minus 3 pi over 5 leaves us with 2 pi over 5. That's our reference angle right here. Okay, so we've now calculated how to find reference angles. Now we've got to get back to the actual trig portion. So we have a little bit of a process. It's easy, okay, to find the value of any trig function at any angle theta. Now we're lucky because everything that we're going to find in this lesson will fall somewhere in this nice little graph for us. Okay, but we're working step by step here. So here it is. To find the value of any trig function at any angle theta, we're going to determine the reference angle, which, good thing I just showed you how to do that. And step 2, we're going to put the appropriate sign based on the quadrant. I talked about that. Depending on what quadrant it falls in, we're going to take these values and we're going to slap on whatever sign is needed. Okay? So it's not too difficult. We're just combining pretty much everything we've done in this lesson so far. Okay? So first, we're going to evaluate sine of pi over 4. We need to know the reference angle. Figure out what quadrant. 5 pi over 4 is slightly more than 1 pi, so we're over here in quadrant 3. We need the reference angle. So quadrant 3, working in radians, says theta minus pi. So let's see. 5 pi over 4 is theta. We want to subtract pi, which is equal to 4 pi over 4, right? That's just 1 pi. That's going to give us pi over 4. That's our reference angle, right? Theta prime. But we have a couple of things that's happening here, right? We know that we're in quadrant 3, which means that we know that sine is negative, cosine is negative, and tangent's positive, right? But what's more important is we have negative x and negative y. Okay, we need those signs. That's what's really key here, because our reference angle ended up being pi over 4. And we know what those coordinates are. They're negative root 2, I'm sorry, they're root 2 over 2 and root 2 over 2 for pi over 4. But because the quadrant that we fell in was quadrant 3, we're going to tag on those negative signs. So we got negative root 2 over 2, negative root 2 over 2, because we were in quadrant 3. Okay, so when we want sine of 5 pi, over 4, it's going to be equal to, let's see, sine is going to be our y coordinate. So we want negative root 2 over 2, our y coordinate. That's your solution. Okay, so it was actually kind of easy once you used all of these things in conjunction with each other. Okay, let's evaluate a new one, right? Tan of 50 degrees. What do we do first? We looked at what tan of 150 degrees, where it fell, what it looks like. It's less than 180, more than 90. That falls in quadrant 2. So there's some things that we need to know. First, we need to know that reference angle. So we look at our reference angle sheet, right? Reference angle, for quadrant 2, working in degrees. We take 180, we subtract theta. So 180 minus 150, we're working here at 30 degrees. Now, some key pieces of information. Quadrant 2 has negative x and y, so we need to change x to negative. And we're working at 30 degrees. Here's 30 degrees. Okay? Our coordinates are square root of 3 over 2 and 1/2. But quadrant 2 says negative x. So we need to change that to negative root 3 over 2. Negative root 3 over 2 and positive 1/2. Now we're working with tan. Tan of 150. We want y, which is 1/2, over x, which is negative root 3 over 2. Okay, fractions. Dividing by fractions. Easy to deal with. Right? We just multiply by the reciprocal. So we got 2 over negative square root of 3. Here our 2's cancel. Alright, negative 1 over root 3. Okay, rationalizing. We've done this a bunch of times in this video especially. Right, root 3 times root 3, that's root 3 squared, which is now just 3. And we got negative root 3 now on top. So here it is, tan of 150 is equal to negative square root of 3 over 3. Right? All those things working in harmony together. Okay, so we've got one more example for you to try now. Pause the video and resume when you're ready to check. Okay, I'm crossing my fingers for you on this one. These are really tough. So let's see how you did. We start off by checking out what this angle theta looks like. 5 pi over 3. 5 pi over 3. Let's see. 1 over 3, 2 over 3, 3 over 3. 4 over 3, 5 over 3 is in quadrant 4. So we need quadrant 4 information. Quadrant 4 information says positive x, negative y. It also says 2 pi minus theta for our reference angle. So 2 pi over 1 minus 5 pi over 3. We also want x and negative y. I'm just going to make that note here. Okay, in order to make these match, we multiply by 3 over 3. So that's 6 pi over 3 minus 5 pi over 3 is plain old pi over 3. Now, working with this and this, we look at pi over 3 up here. Oops, pi over 3. Our coordinate is 1/2 and root 3 over 2. 1/2. We want negative on our y. Okay, cosine is x. Here, x is 1/2. So cosine of 5 pi over 3 is equal to 1/2. Don't believe me? Check the calculator. Anyways, you should have gotten that same answer, so you should believe me. And I know you got it because I know that you're smart enough to get these. So, if you have any questions about this stuff, bring them in to class and we can answer them there. If not, maybe leave them on the message board. Somebody can pick them up and help you out there. Well, Trig is not the easiest in the world, but I know that you can get it if you keep on working at it. And there's tons of other websites out there that can help you. So if this wasn't the best one, check out some other videos. Alright, talk to you guys soon.